Question 1 starts you off asking where y equals 3 to the power of x meets the curve y equals 10 take away x cubed. So the first thing you're going to do, because they want to equal each other, is you want to make these two things equal. So you write one thing equals the other. Rearrange this all to stick it all on one side. And that would be equaling 0. And so we could say that we have a function here. F of x equals 3x take away 10 plus x cubed. Our job is to show that the root lies between 1 and 2. So we're going to work out what f of 1 is. When you tap f of 1 into the calculator, you get -6. When you tap f of 2 into the calculator, you get 7. And so now we write our statement here about the change of sign and say, therefore, the root lies between 1 and 2. 1 is less than alpha, is less than 2. You can't just write, therefore, there is a root. You can't just write, therefore, a root lies between them. You need to write something more than just that. Part B then. Part B asks us to just rearrange it into the form x equals that. So we've got a cube root. So where should we go from? Let's go from here. 3x equals 10 take away x cubed. Add the x cubed to both sides. And then take away that 3 to the power of x from both sides. So x cubed equals 10 take away 3 to the power of x. And so x equals the cube root of 10 take away 3 to the power of x, just like you were asked to show. And the last bit just says put in the value 1 into there, and when you use that on the calculator, you get x2 to be equal to 1.913. And x3, by putting 1.913 back into there, that turns out to be 1.221. Make sure you've got all of those decimals there, because it does say leaving your answer to 3 decimal places.